Hello everyone. Today we will going to see some practice questions from the topic electrochemistry, and this is part 3. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is the index slide and we will going to see the practice questions from question number 17 to question number 23rd. Let's start with the question number 17. Standard reduction potential values of three metallic cations X, Y, and Z are 0.52, minus 3.03, and minus 1.18 volt respectively. The order of reducing power of corresponding metals is, we have given the reduction potential, standard reduction potential values for X, Y, and Z cations, and we have asked that the order of reducing power of the corresponding metals for X, Y, and Z is. Okay, so we have to tell the order, increasing, decreasing. So options are Y is most, then Z, then X is most, then Y, then Z is most, then Y, then X, or Z is most, then X, then Y. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The answer is option A, that is Y is the most and then Z the next. So we have given that the standard reduction potential of XYZ are this, and this, right? So greater the reduction, we have to know this concept that greater the reduction potential, less is the reducing power of that particular metallic cation. Okay. So if you have the greater reduction potential for any cation, that means the reducing power for that will be lesser. Okay. So we can simply just see at the reduction potential values. The decreasing order of reduction potential is this. That means the most highest or the largest reduction potential is of X 0.52 because it is in positive, rest two are in negative. Then if you compare the negative ones, the greater will be in the Z and then it will be in Y, right? So this is the order, decreasing order for the reduction potentials of the given metallic cation. That means if you have to arrange the reducing power of these, we can arrange it like Y is having the most reducing power, then Z, and then next. That is opposite of this one order, right? So order of reducing power of corresponding metals is this. And thus our A option is the correct answer. Okay, moving to our next question number 18. The metal that cannot be obtained by electrolysis of an aqueous solution of its salt is. So a metal that we cannot obtain by the electrolysis process of an aqueous solution of its salt, of that metal salt. Okay, so the metal will be, options are silver, calcium, copper, or chromium. So you have 10 seconds to solve this question. After that, we will see what is the correct answer. Okay, let's see the answer. So the correct answer is option B, that is calcium. So higher the position of element in the electrochemical series, more difficult is the reduction of its cations. Electrochemical series, you know, that in which the metals or the elements are arranged in an order of increasing or decreasing reduction potential values, right? So the higher position of any element in the electrochemical series means that it will be more difficult uh, for reducing of their cations. Okay, So if Ca2 positive, calcium 2 positive is electrolyzed, water is reduced in preference to it. Okay, so calcium come at the higher position in the electrochemical series compared to the elements given in the option. So that means if we electrolyze the calcium 2 positive aqueous solution, water gets reduced in preference of calcium, because as the position is higher, more difficult will be its reduction. So water gets reduced in preference to the calcium 2 positive ion, and hence it cannot be reduced electrolytically from their aqueous solution. So this process can't be used for the reduction of the Ca2 positive. And this is the process, you can say that Ca2 positive plus H2O, and on the reduction it will giving us Ca2 positive exact Ca2 positive plus OH minus plus H2. H2O get reduced, water get reduced in place of calcium 2 positive. Okay, so calcium is the metal that cannot be obtained by the electrolysis of an aqueous solution of its salt, and thus B option is the correct answer. Okay, let's see the next one, that is question number 19. So it is given that E naught for the chlorine ion is 1.36, E naught for the chromium 3 positive and chromium is minus 0.74 volt. E naught for Cr2O72 negative Cr3 plus is 1.33, and E naught for MnO4 negative Mn2 positive is 1.51. The correct order of reducing power of the species chromium, chromium 3 positive, Mn2 positive and Cl negative will be. Again, we have to tell the correct order of reducing power of the species given in the questions, for which E naught is given in the question, right? So options are that the most reducing power is for chromium, then chromium 3 positive, then chlorine negative, then Mn2 positive. Or chromium, then chlorine, then Cr3 positive, then Mn2 positive. Chromium, then Mn2 positive, then chlorine negative, then Cr3 positive. Or most is the Mn2 positive, then chromium, then Cl negative, then Cr3 positive. So you have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. It is option A. So this is the correct order of the reducing power of the species for which the E naught is given. So the concept is that more the negative value of reduction potential, higher will be the reducing power of that particular species. Okay, so you can see that the most negative value for the Cr3 positive is present, right? Basically chromium, you can say, because E naught for chromium is given as this, for chromium 3 positive is given this, and for Cl negative it is given this, and for Mn2 positive it is given this, right? So we have asked the reducing power order for these species. So most will be for chromium, because the most negative value is for chromium given. So chromium, then Cr3 positive, because in the order more than this, first come is this one, Cr3 positive 1.33 volt. Then after that it will come 1.36, and then after that the highest E naught value, reduction potential value, is for Mn2 positive, and hence lower will be the or lowest will be the reducing power for the Mn2 positive. That's why it is an ending, or it is in last in the order. So this is the correct order for the reducing power of these species. Okay, so chromium most, then chromium 3 positive, then chlorine negative, then Mn2 positive, as per their reduction potential values given in the question. Okay, and thus A option is the correct answer. Okay, now let's see the next question, question number 20. It is given that E naught for chromium is minus 0.74 volt. E naught for Mn2 positive is given as 1.51. E naught for chromium 3 positive is 1.33, and E naught for Cl negative is 1.36. Now, we have asked that based on the data given above, strongest oxidizing agent will be. Okay, so we have to tell the strongest oxidizing agent. Oxidizing agent is the one which gets which oxidize the another substances or another element and gets reduced itself. Okay, so the options are chromium 3 positive, Mn2 positive, MnO4 negative, or Cl negative. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. So it is MnO4 negative. As per the data mentioned in the question here, MnO4 negative, this one, is strongest oxidizing agent at it has maximum SRP, standard reduction potential value. So it will be reversed, right? So if you have the highest reduction potential value, so the reducing power will be lowest, but the oxidizing power will be strongest, right? And we just use this concept here, and we can see that the highest value for the E naught is for MnO4 negative, that is 1.51, which is highest among the given values, right? And that's why MnO4 negative is the strongest oxidizing agent as it has maximum standard reduction potential value. So by using this concept, option C is the correct answer. Okay, let's move to the next question. Question number 21. Electrode potentials E naught are given below. So it is given that E naught for copper is 0.52 volt, E naught for Fe2 positive is 0.77 volt, E naught for I negative is 0.54 volt, or E naught for Eg is 0.88 volt. Based on the above potentials, strongest oxidizing agent will be. Options are copper, Fe3 positive, Ag positive, or I2. So you have 10 seconds to solve this question. After that, we will see the answer. Okay. So option C is the correct answer, that is Ag positive. Again, the same concept we use here also, that more the positive value of electrode potential and stronger will be the oxidizing agent, represent the Ag positive is the strongest oxidizing agent, because you can see here that Ag positive having a largest, or the largest among the all the given electrode potential values, which is 0.88. Okay, and hence this will be representing the strongest oxidizing agent. So Ag positive will be the strongest oxidizing agent as per the given data in the question of electrode potentials, and thus the C option is the correct answer. Okay, let's move to the next question. Question number 22. In the cell reaction, copper plus 2 Ag positive giving us copper 2 positive plus 2 Ag. E naught for this cell reaction is 0.46 volt. By doubling the concentration of copper 2 positive, this one here present in the product side, the E for the cell is. So what will be the effect on the E of cell, potential of cell, when we increase the copper 2 positive concentration, when we double the copper 2 positive concentration, and copper 2 positive is present in the product side. You can see here as per the reaction. E naught cell for this reaction is given, which is 0.464. Options are doubled, halved, increased but less than doubled, decreased by a small fraction. You have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see the correct answer. The correct answer is option D, that is decreased by a small fraction. So we have given the E naught cell value. We have to tell the effect of E of cell value on uh, by the doubling of concentration of Cu positive. So we just use the Nernst equation here, which is E of cell is equals to E naught of cell minus RT by NF ln product side concentration divided by reactant side concentration. So Cu2 positive oxidized state divided by reduced state, and Ag positive whole square, because 2 is the stoichiometric coefficient with the Ag positive, so 2 will go in the power. Okay, and this is the Nernst equation. E cell is electrode potential, E naught cell is standard electrode potential. So you can see clearly that if we double the Cu2 positive concentration, that means this will increase, right? We just introduced 2 here. So if we double, the doubling of Cu2 positive decreases the EMF by a small fraction. So how this will going to affect? So if you put 2 here, concentration will be double, right? If you put 2 here, it will come here in the power, and it will become square. So numerator is increasing in the ln, so ln value will be increased. So the E cell value, EMF of a cell value get decreased by a small fraction, right? So as per the options given, D option is the correct answer. Okay, let's move to the next question. Question number 23rd. For the reaction zinc plus copper 2 positive, copper 2 positive concentration is given as 0.1 molar, giving us zinc 2 positive, which is 1 molar plus copper. Taking place in a cell, this reaction is taking place in a cell. E naught of the cell is 1.1 volt, and E of cell for the cell will be. So we have to find out the E cell value, that what it will be. E naught is given here, and it is given that 2.303 RT by F is equals to 0.0591. So we will take this value as equals to this. Options are 1.8 volt, 1.07 volt, 0.82 volt, or 2.14 volt. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see the correct answer. So the correct answer is option B, that is 1.07 volt. So again, we apply the Nernst equation for finding the E cell value. E cell is equals to E naught of cell minus 0.0591 divided by N log product or oxidizing state upon reduced state. So zinc 2 positive upon Cu2 positive. And we have given the concentration for Zn2 positive as well as Cu2 positive. So, and E naught value is also given. So 1.10 minus 0.0591 divided by 2 log 1 divided by 0.1. So it will become 10, and log 10 is 1. So on solving this equation, we have E cell value is equals to 1.07 volt. Okay. And thus our option B is the correct answer. Okay. Okay, thank you.